Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ant. In this tutorial video, we'll continue this work 3 tutorial for the combined science 14 to 16 years old GCSE, IGCSE O Level Chemistry contents for combined science students. So in this first question, so the science teacher give a student this apparatus as shown. We have some beaker as well as a pipette, and this is an indicator. These are solutions of acid, X, Y, and Z. This is an alkali, this is water. So the student places 5 cm of acid into the beaker and add 1 drop of the indicator. We know indicator can tell us, it indicates whether it is acidic or whether it's alkaline or even whether it is neutral, depending on if it is, universal indicator or not. Now she adds the alkali 1 drop at a time until the indicator changes color. So initially you have acid. So initially you have acid. So 5 cm cube of acid X. And then after that, what you do is you add in some indicator. So this is 5 cm cube acid X plus 1 drop of the indicator plus indicator. Then after that, you're going to add in more and more of the alkali until it changes color. So you are going to add alkali next. And that is basically, so you're going to add alkali until changes color. So this is basically neutralization, because the indicator will change color when it's no longer acidic. So you are doing neutralization between an acid and an alkali. This is straight from the acid, base, and salt topic. Acid plus alkali will give you a salt. It will also give you water. This one will end up with pH 7. Whereas previously acid pH is lesser than 7, alkali pH is greater than 7. The more greater number of drops, the more drops you have, therefore you have more acidic. Because if you are more acidic, you will need more alkali. This is of the alkali to neutralize, and that is why you need more drops of the alkali to neutralize the greater amount of acid you have. Therefore it's a stronger acid. As you repeat with Y and Z, Z require the least. Therefore, what I can say is Z is the least acidic, and then X is the most acidic. So based on the information given here, this is the color of the indicator at different level of pH. At pH 5, this is lesser than 7. So in acid, it is red. And then at pH 9, this is greater than 7. So this is alkaline. Or basic, that is when you have OH minus called hydroxide ions. These are all from acid, base, and salt topic. So state the color of the indicator. In acid, is going to be red there. Whereas in alkali, the pH is greater than 7, is going to be orange color there. Now, which of the acid solution is the most concentrated? So this one comes from year 9. Year 9 under reacting amounts. The very, very last bit of that topic on reacting amounts is to do with concentration. The most concentrated acid will require the greatest number of drops of alkali to neutralize. More acid require more alkali to neutralize. So X require the greatest number of drops. X is the most concentrated. So the more concentrated the acid. So what do we know about concentration? So the more concentrated the acid, the more H plus it contains. This is definition of acid. And the more H plus you have, therefore you need more OH minus, which is the hydroxide ions from the alkali to neutralize, and therefore you require more drops of the alkali. Therefore more drops of alkali is needed. Okay, the next question suggests why the beaker of water is needed. As you do one experiment, the next, you repeat the experiment with Y and Z. Y and Z are different acid, so you're using just one pipette, and therefore you have to wash the pipette with a little bit of water before you do for the next acid, otherwise it won't be accurate. This is to help to rinse out the pipette, the dropping pipette actually. or you can say the dropper in between using the acids. In between using the different acids, you have to rinse out, just like when you use a scooper to take out some ice cream. Before you go to the next flavor, you have to, you know, rinse out the different flavor of the ice cream, just like that. Now name and alkali. Name, alkali. Alkali means soluble base, so you got to have something which is soluble base to be used in this experiment. You could perfectly use things like aqueous sodium hydroxide. So aqueous there means it's a solution, it means it's soluble in water. So you could use sodium hydroxide, you could use aqueous potassium hydroxide. And another one which is very, very common to you, which is alkali, is going to be ammonia. So those are all perfectly fine. Can't give the formula because they want the name there. Now the student wants to find out the name of the acid, the name of the acid. She places 2 CNK of solution X in a test tube at aqueous silver nitrate. Silver nitrate is test for Cl-, Br-, and I-. You gotta see your qualitative analysis table. Chloride, bromide, iodide is tested with silver nitrate. Give you white precipitate, cream precipitate, yellow precipitate. You get a white precipitate, it means it has to be the chloride, not the cream color silver bromide, not the yellow color iodide. So what is the name of the white precipitate? You will have silver chloride. That is your white precipitate. Now how in the world do we get the chloride? We have just added silver nitrate, so the chloride must have come from the acid. So the acid contains H+. All acids contain H+. What else do we know? It also has Cl-. You gotta see the test for Cl- previously. So you gotta be HCl aqueous, but this is formula. They don't want the chemical formula, they want the name. The name is called hydrochloric acid, part of your vocabulary. In part F, how you could use pieces of magnesium ribbon. Which of the 3 solution is the most concentrated? This is to do with rate of reaction. In this rate of reaction stuff, we got to think about what is constant. Constant means not changing. That will be your control variable. Control variable means what is not changing. Then you got to think about what is changing. So what changes? And what is changing will be your y-axis, and that will be what you call the dependent variable. These are straight from lower secondary science. Lower secondary science, year 7 and year 8. And then the last thing is what to measure. What you are measuring is called the independent variable. Independent variable is what you need to measure in a reaction, in this kind of experiment. So what do we need to keep constant? The first one, well, let's see. Let me choose this color. So keep the amount of magnesium, the amount or the length or how much you use of the magnesium constant, because you don't want that to change. What else? Keep temperature constant. Keep temperature constant. Keep the volume of acid constant. So the volume of acid used constant. And why? Because we are just dealing with concentration, so we don't want to change too many things of the acid, so we keep the volume of acid constant as well. So that first bit is to do with control variable. Control variable in the experiment means do not change it. So what are we changing? So change only the concentration of the acid. So basically the different acid you use, i.e. use acid X, Y, and Z. As you were told, X, Y, and Z have different concentrations, and our job is to find out which one is the most concentrated by a different method using magnesium. So this is the reaction between metal and acid. So metal plus acid. So you have magnesium plus acid actually, so I don't need to write generic. I know the name. Magnesium plus the acid, they will give me the magnesium salt, which is the metal salt. and also hydrogen gas. The key factor here is hydrogen gas. So it is a gas. So what can I measure? So therefore, measure the volume. Measure the volume of hydrogen gas released or hydrogen gas produced in a fixed time, in a given time. So if I say in 1 minute, how much hydrogen gas is given out, I gotta do the same for the other two experiments so that the time is not changing, but the volume is what I measure. The question is, how can I use that information to tell me which acid is the most concentrated? The more concentrated the acid, the faster is the rate of reaction, right? The more concentrated the acid, faster reaction. If your reaction is faster, therefore we get a greater volume, or we get more gas collected or measured. The question is about how, and also describe. That means a lot of details. In experimental details, what do you keep constant? What do you change? What do you measure? So what you measure is what you call the dependent variable, and what you change is what you call the independent variable. So this is the independent variable. As you change the acid used, the different concentration of the acid used. These three different variables, they are straight from your lower secondary science. In question number 2, these are words and phrases about gas tests. As you have done quite a lot of tests for gases, including chlorine, including CO2, H2, O2, and also NH3. Use a ruler to construct a table, each gas with its test. Number 1 is for the gas, number 2 is for the test, number 3 is for the positive result. So let's identify the gas first. So carbon dioxide is the gas, CO2. Oxygen diatomic gas, we have 21% of it in the atmosphere. And we have hydrogen gas there. And if I have my gas, so number 1 would be carbon dioxide, for instance. So what is the test for carbon dioxide? The test is just using lime water. And what happened to the lime water? The lime water will turn milky. So the lime water will, where is lime water turn milky? White precipitate. That means the lime water turns milky, the lime water turns cloudy. That one was part of the experimental tutorial, which you would have seen in the playlist as well. Number 2, let's say I go for oxygen gas. Oxygen gas is using glowing splint. So that means you don't have the actual fire, you just have the flicker. So that's using glowing splint. And what happened to the glowing splint? It will relight as it sparks back into flame, because oxygen supports combustion, oxygen supports burning. Last but not least, I have hydrogen. Test for hydrogen is using lighted or a burning splint. The other name for lighted is also burning splint. It's the one where the flame is still going on, in contrast to glowing splint. So we use a lighted splint. If you are used to writing burning splint, you gotta read the question here is lighted splint. It burns with a pop sound. So it burns with a pop sound. And that's characteristic of hydrogen gas there. And that's it really for that question. 4 marks. In these next questions, we have 5 different tests, and we are testing on the solution sodium hydroxide. These are solutions. Solution means aqueous, dissolved in water. It means dissolved in water. So you have NaOH, aqueous, so it's a soluble solution. Ammonia, NH3, vocabulary from year 9. Sulfuric acid, H2SO4, another vocabulary. Same with hydrochloric acid, HCl. These are from year 10, acid, bases, and salt topic. So what do we have here? If no reaction, write no change. But if there is a reaction, you gotta write observations. What do you see? What do you see? Okay. There should be a statement in each blank box. So you gotta write something in every single blank box. So universal indicator is used to test for acid and alkali. So it will be red in acid, So that means the pH is lesser than 7. It will be purple if it is well, purple or blue. So but this is NH3 aqueous, so it will be blue there. So aqueous sodium hydroxide, it should go purple, so purple solution formed, so a much darker shade of blue essentially. So it's a result of the different pH values of the solution. Ammonia is around pH 11 or pH 10. This is around pH 14, the most basic solution compared to ammonia. Hydrochloric acid and sulfuric acid, this is around pH 2 and pH 2. So they will be around red color rather than orange yellow, because orange yellow is for like pH 5, pH 6. So dilute hydrochloric acid will go red solution. So indicator here refer to the solution, so not using the universal indicator paper. So therefore, we get the change in the color of the solution. This is as stated in the syllabus, describe the changes of universal indicator in acid and alkali, straight from acid, bases, and salt topic. The next one, equal volume of silver nitrate. The key question here is silver nitrate is used to test for chloride, bromide, iodide ions, and you will get a white precipitate, cream precipitate, yellow precipitate. So here they already told you something, brown precipitate, because sodium hydroxide contains OH minus, and we know that OH minus can form a lot of hydroxide precipitate. Think about your test for cations with all this sodium hydroxide, always give you a precipitate there. This is hydrochloric acid, so it has got Cl minus and also H plus. Sulfuric acid, H plus, and SO4 2 minus ions. As stated from the formula of hydrochloric acid, you got Cl minus chloride. Sulfuric acid contains sulfate, SO4 2 minus ions. Because you have 2 of the H plus, that means you must have 2 minus there. You have chloride, you have tests for chloride using silver nitrate. So what you will get is white precipitate will forms. The next bit, we have barium chloride solution. So this barium chloride solution is basically test for sulfate. Sulfate comes from sulfuric acid. So that's why we get a white precipitate there. When we tested it with hydrochloric acid, Cl minus will not give us anything with the sulfate. So there will be no change. This is white precipitate because that is your test for sulfate, which is positive from the sulfuric acid. So this is the positive test there. The next one, copper 2 sulfate solution. So this contains Cu2 plus aqueous. It's a pale blue solution, as you have seen in the experimental tutorials on qualitative analysis. When we added sodium hydroxide, it's a different observation with ammonia. This is copper 2 plus in sodium hydroxide versus ammonia. So here, I will get a blue precipitate. So better write that down. Pale blue precipitate forms. So precipitate forms. What happened in excess? This is insoluble in excess. It's the same story with ammonia, but the precipitate is soluble in excess. So this is the key difference here. So this is soluble in excess ammonia, which is the second column. When it's soluble, what do you form? You get a dark blue solution. If you watch the tutorial video, the experimental tutorial video on the test for copper 2 plus ions in ammonia versus sodium hydroxide, you would know what I'm talking about. You would have done this in school if I had shown you the practical as well. The next bit, you have magnesium riband. So this is a metal, and this gas evolve means release. You test with a lighted splint, which is the same as a burning splint. So this is a reaction of metal, reactive metal like magnesium, posocarmazil. Magnesium is up there, reactive metal. Metal plus acid will give you metal salt. But they also give you a gas, and this gas is called hydrogen gas. It's a diatomic molecule. where the hydrogen share 1 electron from each hydrogen atom to complete the outer shell, and as such they form a covalent bond there, diatomic molecule, 2 atoms forming covalent bonds bonded together. What we have here is sodium hydroxide and ammonia. These are base. They don't do anything with the metal, so no change at all. We don't get any gas at all. And then with the acid, both the hydrochloric acid and the sulfuric acid, they will react with the magnesium metal, and what we will get will be bubbles, a lot of bubbles. So you can say bubbles, or you can use the word effervescence, just like when you test for carbonate, because even though we don't have carbonate here, but when you get a lot of gas, we get effervescence. And in both of these cases, we produce hydrogen gas. So in our second bit, so the gas burns with a pop sound. So the gas, the lighted splint burns with a pop sound. Lighted splint give pop sound. So the pop sound is the test for hydrogen gas. And you do get hydrogen gas when acid reacts with metal. In both of these cases, both the hydrochloric acid as well as sulfuric acid will give you hydrogen gas, which burns the lighted splint with a pop sound. And the reason you test for gas is because you see the bubbles or the effervescence there. That's all really for this work 3 tutorial for qualitative analysis 14 to 16 years old combined science curriculum. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel, and do follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter and Telegram to get connected. Thank you for watching again. I'll see you in the next tutorial video.